Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at, factoring a difference of squares. And so why don't we go ahead and see what that's about. So when you're trying to factor with the difference of squares, there's a pattern that you're going to look for and that you're going to see that can be exploited to take advantage of this. So the basic pattern is kind of something along these lines. When you have the square of the term a, if you will, minus the square of the b term, and you can get the following broken out factor of a minus b in parentheses here, and then a plus b, like so. That's what it is. So what happens is that generally either you start with this to get this, or vice versa, you start with this to get this. And so let me see if I can give you an example to make this a little bit clearer. So let's say we have the example here, 121 m squared minus 1. So now obviously you can see that the 1 is not squared, but we can put the 1 here just to complete it, but that's not necessary. And so what happens is that you square the term. That's why we're looking for, a difference of squares here. So if I square 121, well, the square root of that is going to be 11 m, like this. And so also right here, I still have my 1 square, nothing changes there. And now, here's the thing. 11 m squared means I have two 11 m's, obviously. And then I still have my 1 squared here. And so what I do is now that I factor this and I just follow the pattern, and I end up with the following. I end up with 11 m minus 1, and then I end up with 11 m plus 1. Now, by doing that, I'm able to, remove excess information here because the minus sign helps to deal with, having the extra 11 m's or whatever. This will make more sense if you work it out longhand, which I should probably do on the next slide. So I have here 11 m minus 1, and then I have 11 m plus 1, like so. So let me go ahead and show you what's happening here. So when I do 11 m times 11 m, I get 121 m squared. That looks familiar. And then I do 11 m times that one, so plus 11 m. And then of course I do 11 m times that one, minus 11 m. And then I do 1 times, negative 1 times 1 is going to be minus 1. Now you can see here clearly what's happening. These cancel out because 11 m, positive 11 m, minus 11 m is going to become 0, and then I'm still left with the following, 121 m squared minus 1, which is what we had in the beginning. And that's the power of this. When you have these opposite signs here, they cancel out, the first power to the power that's to the first power, if you will. And that's what's happening there. And so this is how this pattern works. Now let me just do one more example to make sure things are clear. So imagine we have here, let me do, how about 81 y squared minus 25. Again, we square everything, and so now we have 9y squared, and then we have minus 5 squared, like so. And then you just follow the pattern that you saw on the first screen. Here's the pattern right here, a minus b, a plus b. And so what do we have? This is my a, this is my b term, if you will. And so now we end up with the following. 9y minus 5, 9y plus 5. And again, you can unpack this if you want to see if it's correct. But you can see how you can follow the same pattern every single time. But there is one more thing that is somewhat interesting. The a squared minus b squared works, where you get this pattern, a minus b, a plus b. However, many times, often, a squared plus b squared will not work. In other words, it will not work out to where you have this a minus b, a plus b, or whatever you want to call it. It doesn't work many times. Now you can play with this on your own and try to figure out why, but because these are examples of special situations of factoring, when you add the two terms together, oftentimes it will not work. And again, you can play this on your own time, but I just wanted to point this out because people might be wondering, hey, you said a squared minus b squared, well, how about a squared plus b squared? Well, oftentimes it will not work. I'm sure there's exceptions, but I have not encountered one in the time that I spent exploring this. So let me go back and explain what we did in this video. In this video, we looked at how to factor differences of squares. And so basically what you do is you look for this pattern, a squared minus b squared, and you can unpack it to where it's a minus b in parentheses times a plus b in parentheses. And we have the example right here where we took 121m squared minus 1. We squared it. We squared both numbers, but of course this was the number 1, so there was nothing to square. And then we followed the pattern. We put the square root of 1 here, and the square root also here, and also we put the square root of the other two terms as well, following the pattern of minus 1 and plus 1. And when you do this, you're able to quickly square, particular polynomials that you might encounter as you're trying to factor and deal with things in an algebraic situation. So I hope this video was useful for you and that you were able to understand what we were talking about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.